I'm Carl Anthony, Managing Editor of AutoVision News, and welcome to AutoSens Insights. We're speaking today with Chad Kobylanski. He's an automotive segment manager with Shinetsu Silicones of America. And Chad, welcome today to the program.
Yeah, thanks, Carl. It's great to be here. We are a first-time presenter and sponsor for AutoSens, so we're really excited.
And this is exciting, Chad. So as I was going through my email and as I was getting my interviews organized for AutoSens 2020, the Detroit edition coming up, I saw your name and I saw Shinetsu Silicones and I thought, this is exciting because it's the first time I'm meeting you. It's the first time I'm meeting your company. So please tell us a little bit about yourself and tell us a little bit about Shinetsu Silicones.
Yeah, thanks again, Carl. I'm Chad Kobylanski, Automotive Segment Manager for Shinetsu Silicones of America. We are the wholly owned U.S. subsidiary for the silicone division of Shinetsu Chemical. And a little bit about our company. Shinetsu was founded in 1926 as Shinetsu Nitrogen Fertilizer Company, which was renamed later in 1940 to Shinetsu Chemical. We have over 19,000 employees globally, and our corporate headquarter offices and branches are located in Japan. Shinetsu has many market-leading product divisions. We are the worldwide leader in the manufacturing of PVC, semiconductor silicon, rare earth magnets, synthetic quartz for photomasks, synthetic pheromones, and number 2 worldwide in methyl cellulose, and number 4 in silicones.
So I guess, Chad, that's a good segue then to my next question. When at the AutoSens conference, we have engineers from all different backgrounds, right? And so I'm sure one of the questions they're asking right now is how is Shinetsu different from other material suppliers in the market?
Yeah, so one thing that really separates Shinetsu from other material suppliers is that we like to work directly with our customers to formulate products that work specifically for them and their application. This offers the customer an advantage by providing a unique solution for their market over their own competition. And we have R&D facilities positioned around the globe to offer this fast product development. And with our production facilities in the United States and these locations overseas, we have built a supply system that gives us direct access to regional markets, which greatly reduces our lead time on products for manufacturing as well around the globe.
Sure. So let's talk about silicone, which is obviously in your company name, but you know, over my years as an automotive journalist, I've spent a lot of time writing about aluminum, spent a lot of time writing about high strength steel, but silicone is also important. So when it comes to the automotive sensor market, what are the opportunities for silicone?
Yeah, so around the autonomous vehicle, there are hundreds of applications that require silicone, from lighting to power electronics and the countless amount of sensors. These are going to require a tremendous amount of material support to validate and really improve the safety and reliability of the current LiDAR and sensor automotive markets as the levels of autonomy increase. Shinetsu currently provides materials to the automotive and sensor markets, so we decided to combine our resources and materials from different divisions to provide each customer with as much material support as possible for LiDAR and sensor-related applications.
So, Chad, what specific products do you have available now that will facilitate and support the design and growth of the automotive sensor market?
Yeah, so similar to the trend in LEDs, which are becoming smaller and brighter, these LiDAR and some pulse sensors, these are using high power lasers that send out countless pulses of light, which push materials, components, substrates to the limit in thermal stability. For example, cracking is occurring in older silicone and other material organic encapsulants that can't handle these new high power designs and thermal shock testing that you'll see in the automotive market. Our latest silicone dimethyl encapsulants can withstand up to 270 Celsius for over 2,000 hours. And as corrosion on chips and lead frames becomes a bigger issue, our high gas barrier and refractive index properties from our latest phenol encapsulants can survive up to 2000 Celsius long-term. And Shin-Etsu recently developed a new black encapsulant that blocks visible light and only allows IR, infrared radiation, to pass through. It's one of the first silicone products on the market and is superior to standard epoxy and other organic type films due to its high elongation for resistance against cracking and overall higher thermal stability. And for vertical cavity surface emitting lasers, or VCSELs, we developed a UV curable high transparency gels, silicone gels that can absorb the stress from the VCSEL package with no curing shrinkage. So that's a big difference there. And we also developed for MEMS mirrors and CMOS sensors. We also developed new Loca Materials, which is liquid optically clear adhesives. These are an excellent choice to bond and seal transparent parts or displays. These materials are available in different curing schedules. So we have radical cure options, which cure within seconds with exposure to UV wavelengths and lighting. And we also have heat cure options if UV is not suitable for products. And our new curing system offers a dual cure, which is a UV plus heat, which is a great way to fixate non-transparent and components or cameras on the modules or devices. So you basically, you activate the cure by exposing to UV for a matter of seconds, and then you position the component onto the board or device, and then you complete the adhesion and cure by temperatures as low as room temp or with heat acceleration to quickly complete the cure and make sure adhesion to your substrates is 100% complete. So silicone is a great option here for displays also inside the vehicle. Touch screens due to its inorganic properties that give it excellent heat and cold resistance, weatherability, and also the bonding to difficult substrates and chemical resistance to oils from from your own fingernails. And we also provide silicone potting gels and thixotropic encapsulants for electrode protection and light shielding. These potting gels offer a low modulus and maintain a stable modulus over a wide range of temperatures, and again, as well as providing excellent chemical resistance. And another way silicone is helping the overall long-term reliability of sensors in the automotive market is by our thermal interface materials known as TIMs. These electronic devices are generating a ton of heat, and without the proper way of dissipating that heat, you could be jeopardizing the lifespan of these devices. Shin-Etsu offers a full product line of liquid dispensable thermally conductive gap fillers, grease materials, adhesives, potting agents, along with soft hard pads and phase change materials. So instead of using a die cut thermal pad, our new thermally conductive gap fillers, which is the SDP series, can be dispensed in between uneven substrates or even a circuit board and a heat sink, and can be cured at room temperature conditions. And we also developed a product line of thermally conductive pre-cured gels, the CLG series, that range from 1 to 7 watt per meter Kelvin. All of these TIM options are a great way of dissipating the heat away from delicate components. And really, Shin-Etsu is the clear choice for innovative solutions here in the LiDAR and sensor markets. And yeah, we would love to talk to you more about designs and developing more materials for you.
Chad, all of this is so fascinating. And I think one of the big takeaways here is that when you look at ADAS and autonomous driving today, there's things like artificial intelligence, there's things like training data, there's things like machine vision. You get a lot of emphasis on data science and software engineering and computer science, but If I'm hearing you correctly, Chad, what you're saying is that there also should be an emphasis on material science and material engineering with autonomous cars. Is that an important takeaway?
Yeah, absolutely. Shinetsu, we always push the limit of what's possible for materials, and really, it's a partnership with other companies to help develop and push their limits in their own components. It starts also with materials that help support that.
Chad, again, all of this is fantastic, and it's been excellent meeting you, and it's really been a privilege to introduce you into the AutoSens community. So with that in mind, just in the last few minutes that we have, is there anything that you'd like to add or summarize again one more time?
Yeah, again, thanks, Carl, and we're really excited to be presenting here and sponsoring AutoSens. And yeah, we're really looking to work directly with customers to help them to help formulate and push our materials to help their designs for the automotive sensor market.
Well, Chad, thanks for being with us today. From all of us here at AutoSens, we want to wish you the best of luck going forward, and we'll look forward to seeing you in person at a future conference.
Absolutely. Thanks, Carl.
For more great content from AutoSens, check out our hub and our YouTube channel. Just search AutoSens.